Welcome to the EpiDMS demo video. In this video, we will cover registering as a user for the system, the basics of the query page, and the meaning of metadata and similarity results. The goal of EpiDMS is to condense the massive amounts of information we have on previous epidemics into a readable format that will allow the user to find, analyze, and compare similar epidemics. The results enable applications and services to make a significant health and economic impact. EpiDMS enables searching particular temporal patterns on the epidemic ensembles. During an epidemic, this feature allows the expert to identify a relevant subset of stored simulations that match actual disease patterns or specific targets for intervention measures. This facilitates in three public health decision makers. 1. It identifies the relevant parameters that characterize transmission characteristics in near real time. 2. Forecasting epidemic spread as the epidemic evolves. And 3. It assesses potential impact of intervention scenarios. This platform also allows the user to perform simulation refinements by narrowing down the parameter space of possible worlds based on the current state of the epidemic. Hence, the user can use EpiDMS to run additional simulations within the constrained parameter space to obtain more detailed simulations, possibly with additional intervention assumptions that are relevant to the current disease state. Please refer to our paper if you're interested in more details about our system and our research. In order to use the system, the user can either register and activate an account or use the guest login option. This is the login page for EpiDMS, and this is where users will be first brought when they start up the system. The user will be given three buttons: Login, where they can log into the system with a registered account; Register, where they can create an account for the system; and Guest Login, if they want to log into the system without the full functionality of having an account. So we're going to go ahead and show you how to register an account. So go ahead and click Register, and you're going to go ahead and put in a username. Put in a valid email address, because they're going to email you a confirmation email to make sure you can register your account, and a password with numbers, letters, and capital letters. And you want to go ahead and click register and go and pull up that email you registered with, and they're going to actually send you an email to confirm your registration, and just click the link and it'll activate your account so you can log in later. Okay, and for the purposes of this video demonstration, we're going to use guest login to show the full functionality of the system. And the main difference between a guest login and a regular account is you can actually edit and save your own queries with a regular account.
EpiDMS provides a rich query language to specify user queries by utilizing the metadata query page. We will be describing a few functionalities of the page. The query menu will contain a list of previously saved queries that the user can access. For this example, we will choose Sample Query 1. As you can see, when you choose a query, the query box will be filled, as well as a query description. The query description will have a user-defined brief description of the selected query. The query box contains the information on the query chosen, allowing the user to either execute or edit the selected query. The query we have chosen can be broken down into 4 different parts: for, let, where, and return. The for statement will allow the user to select the corresponding dataset to query. In this case, the user will choose from the epidemic set. The let statement will associate variables with the model in order to specify the results. In our case, they will be representing disease and trigger models. The where clause allows the user to specify conditions on the simulation models to filter those simulations that are relevant for the current analysis. In this example, the user specifies that for the return simulations, the transmission rate parameter should be between 0.3 and 0.6. The recovery rate parameter should be set to 0.5, and that a vaccination type trigger should be included in the simulation model. The return clause lists the simulation parameters to be returned in the result. In this example, the user is interested in the transmission rate and the recovery rate. In addition, the query asks the system to return the time series corresponding to infected, incidents, and deaths, simulation output parameters for Arizona, California, and New Mexico. In this clause, the user specifies that he or she is only interested in the first 8 months of the simulation. Furthermore, the user specifies that the system return daily averages of the simulation parameters for the specific duration. The query interface also allows the user to execute parametric queries. These queries support query reuse. Instead of writing a new query for different parameters, the user can specify and store a parametric query which will then be invoked during execution. Surrounding the input value with par will allow the user to specify whether or not the value is parametric. The user can vary these values without changing the source code directly. Once the query is executed and the relevant simulations are identified, EpiDMS then organizes the results in the form of a navigation hierarchy, which is based on the temporal dynamics of the disease. The query identified 60 matching simulations from 2 different disease models. The legend at the top provides the scope of the values and the results. The user can then navigate on this hierarchy using the drill down and roll up operations. The user can then pick a set of simulations to study and compare them in further detail with the corresponding scenarios. Scenarios that result in similar patterns are grouped under the same branch, while simulations that show key differences in disease development are placed under different branches of the navigation hierarchy. For each node in the navigation hierarchy, a cluster representative is selected and the corresponding simulation is visualized in the form of a heat map, where each row corresponds to a location, Arizona, California, and New Mexico in this case. The user can then obtain detailed information about the presented simulations by hovering their mouse over the heat maps. Or they can download metadata corresponding to different simulations for further study. The user can also use the match range feature to change the scale of visualization, so that the upper bound of the visualized values in the heat map are modified in a way that matches the selected simulation to enable better visualization of its details. When clicked, the heat map has been modified to match the number of incidences rather than the number of deaths. Thus, we're able to better observe the differences among the incidence clusters. To further study individual simulations, the user can click at any point of the heat map to place them in a separate comparison interface. In the detailed comparison interface, the user can compare 2 or more simulations side by side. The user can then further ask the system to visualize the precise differences in the metadata corresponding to the selected pairs of simulations. Any differences will be highlighted in red within the XML files. This concludes the explanation for the metadata query. Next, we will look at the other type of query.
Now, the other type of query a user has access to is called the similarity query. And this query basically takes in a simulation as the input, and based on specific parameters chosen by the user, will bring up other simulations that are similar to those parameters chosen by the user as a result. So there are 2 ways to access similarity query. The first way is at the top of the query page. You can actually switch to similarity query, and here you can upload a multivariate time series file, and from there you can choose the project, model, properties, and the zones you want to search for, and just click search similar, and it'll pull up results similar to the results you're looking for. And the other way to access similarity query is to actually go into metadata query, pull up a sample query, and execute that query. And you're going to want to go and drill down the results until you get to the physical data of the simulations. And right here, there's a search similar button, and if you click that, it'll take that simulation and put it as the input for similarity query. And from here, you can choose the project, model, property, and zones. Go ahead and click search similar, and the results are going to show up as similar to those of epidemic of model SIR with the death property in California, New Mexico, and Arizona. And again, you can drill down to the simulations and again search similar and use that as the input for another search similar query. We would like to say thank you for the team that has made this possible. A sample EpiDMS visualization is available at aria.asu.edu. And if you would like to contact Dr. Candon or give us feedback on the system, you may contact us at candon@asu.edu. Thank you for watching this demo video.